And I'm going to start at the waist because I think that's the one that intrigued a lot of people the most. It's like something looks different about that waist. Offhand, any real advantage, there has to be something about improvements in the motion. And we're going to kind of come back to that in just a second. But the main thing here is that, do you ever need to go 45 degrees? Maybe you don't. If you never need to go that wide, then it's not really a problem. And you think about it, I mean, spreading your legs out 45 degrees, that's kind of rare, unless you're trying to do the splits or something like that. And that kind of brings this thing up. This is the downside of having an anhedral angle, is that when you go to flex, your legs will move out in a different way unless you compensate with abduction and rotation at the same time. And right now, I don't think they are. I think the abductor here and the rotation is fixed. And you see how suddenly the feet spread out like that? They slip on the floor because they're trying to rotate that, and that's the result. This is the other thing, the reason why you don't want to have flat feet. Remember, we kind of talked about that either suddenly your feet are on the ground and then instantaneously they're off. This is what their kidney style waist would look like. So you have a Z rotation, and then you have this mechanism here, which allows you to have X and then Y built in. So that optional is this upper bit above the blue part down here that you can put into some of their bots. Let's take a look at what they show their bot doing. So here's walking with a full 3-degree freedom waist. And if we look at this, we can see, and that one there, it was going that side-to-side bending. And then when it was running there, we can see how it was like using the Z rotation. This one uses the Z rotation a lot. As you see, it's very important for the move it's going to do. And you'll see it doesn't actually have an X bend. It's not able to lean forward. So what I believe is that they've got a Z and an X rotation. The question is the order. And I was assuming at first it's like a Z rotation and then followed by an X. And then I realized I'm probably wrong on that. I think there is a difference here of what they've come up with. What they've probably done is the same thing that we've seen in Atom, as I suspect. Again, looking at the silhouette, it's sort of hard to tell. I think in there they've got the room for that actuator, because this actuator up here doesn't look like actuator for rotating in the X. It looks like the actuator that you would use for rotating in the Z. So again, I like the way they framed the question, and this is the way I want everyone to and we're going to see an example here, which is going to be, I think, shows that thinking the problem differently will give you a different solution. So they don't consider that part of the wrist. They consider that part of the elbow. And then the wrist they see as a 2-axis problem. It is a fully integrated 3-axis wrist, no doubt about it. You take away any one of those degrees of freedom and it doesn't work. You need all 3 of them to be able to get these 3 different rotations. You can't split it off. It is a legitimate 3-degree of freedom wrist, integrated in there. Rather interesting, novel design you see there. The other mindset is like, well, how can I solve both of them in one? Well, what kind of approach can I take, and what advantages would I have? And some of them, as I think we've seen in the orbital actuator, is one of the advantages here is that all of your actuators are down here in the cylinder, and you're not carrying the payload of those. So it's kind of a parallel actuation strategy, which has its advantages as well. So again, you can look at these as a different way of solving that problem by looking at the combination of several joints together. I'm not going to say which one's the best. I'm just going to say the mindset is great. Every designer should be taking that mindset and thinking about it, that if I have a 2-axis wrist problem, what am I doing with that first axis, the rotation, the forearm? Am I thinking of it as completely a standalone thing that's sitting on out there? Or wait a minute, maybe I can somehow combine it with my elbow. And if you're clever about it, maybe you get that actuator that's in the forearm right now behind the elbow. You could use some kind of mechanism like what we're seeing here to say, oh, you know what, maybe I can get the actuator for that above the elbow. So that helps me from a dynamic standpoint. Okay, so hi, Mara, how are you doing? How's your weekend so far?
A lot busy, to be honest with you.
Oh, okay. All right. Busy. Well, better busy than not busy, I guess.
Yes.
So the first thing, yeah, is we want to kind of talk about. All right, what is the topic of the day?
Yeah.
Topic du jour, as they might say. And you know what it is?
I assume it's about Unitree. Yeah?
Okay, exactly. So who knows what secrets lurk in the cores of bots? The shadow knows. And of course, why is the topic the shadow knows?
Wow. Sounds spooky.
It's because Unitree teased us about their next generation bot with this last week. And I think if you look at this, it's a little bit of a Rorschach test because what's the first thing you noticed when you looked at this?
Mm. It seemed the shoulder completely different. Bit different.
Okay, you're looking there because I think a lot of people were looking down at the bottom. That's what I'm saying is a Rorschach test that they looked at the price. And, we can yeah, and you can see the question mark is down there, and it's like only one question mark implying that there's only a single digit going in front of the 3 zeros there. So they're kinda teasing maybe a $9,000, definitely, probably under 10,000. That's rather interesting. But of course, the thing I noticed when I looked at it was this, right? Is that, I was trying to figure out what the kinematic structure is. And of course, my eye really went to where it said 26 joint DOF, and especially this notation they use, which is like the same notation I use, which is kind of surprising because I don't think it's a formal notation. It's just an ad hoc notation. But 2 times 6, or sorry, 6 times 2 plus 5 times 2 plus 2. That equals 26. But the mystery might be, what do all these numbers mean? Okay, and basically it means the number of degrees of freedom at all of the critical kind of limbs that you would have out there. And so I did a hot take where I said, okay, going from the ground up, looking at the mystery of what those numbers are, I pretty much believe that 6 times 2 means that 2 legs of 6 degrees of freedom, which are probably their 3-1-2 kind of configuration. The plus 2 implies a 2 degree of freedom waist. And a 5 times 2 probably implies that it's a 3-1-1 arm. In other words, a 5 degree of freedom arm. And you might be saying, well, wait a minute, that's kind of low degrees of freedom. They don't have a full wrist yet. So we'll kind of get back to that. And plus 2, which means probably a 2 degree freedom neck. And so that was my initial hot take, kind of looking at that, looking at the structure and the shadow. And the question is, am I right? So that's what we're going to try to do today. And so just as like a reminder, this is what the current bot, the G1, looks like right now, which is kind of their second generation bot. They had the H1 and H2, which is a different size bot. But from the shadow and everything, the profile looks very much like this. So if we're going to base it on the G1, we can then look at the Unitree page where we get the technical specs. And you see, I went through here and I updated their technical specs with a red pen. So I'm assuming they're going to call it G2. I'm sticking my neck out on that one. Uh, and they said it's 26 off, whereas the current one is 23. So that means we have an increase of 3 degrees of freedom over the original. The leg is currently 6, so I'm assuming, okay, probably right there on that. So they're not adding any more degrees of freedom there. The waist is normally 1 degree of freedom with an option to add 2 more. We're going to get into the details on that. But it looks like they're not giving you an option. It's a 2 DOF waist. That's it. We're going to leave it at that, which means that's an increase of 1 degree of freedom. The single arm degrees of freedom, as you see, they listed as 5, which means that's probably not going to change. So that'll be 0. And then they didn't have a neck degree of freedom before. So I had to scribble that in. And that adds 2. So basically, the increase in the degrees of freedom comes 2 from the neck and 1 from the waist. So that's what's going on. But the question is, did they change anything else that's rather important? So the first thing we're going to try to do is break it down by section. And I'm going to start at the waist because I think that's the one that intrigued a lot of people the most. It's like something looks different about that waist.
He's very slim. Very slim.
Very slim. I mean, overall, yeah, it seems to be very slim in many different places compared to the original. I mean, you can see the family resemblance with the G1. There's a lot of aspects that are similar, but also definitely some differences. Like the head is very different, I think, in many ways. You can almost see what looks like ears up there, which I think is hinting it's probably at audio input. Um, But yeah, let's go ahead and look at the hip. And the first thing to do is that remember we've been classifying the different hips. This is what looks like a classic FAR or far hip, where the flexure is along the red, and then we have the green for the abduction, and then the blue, which is the rotation along the leg itself. Now, what do you notice a little bit different about this versus the earlier design?
I think that we discussed this before. In the earlier design, they don't have this angle in the you don't have this kind of angle. Yeah.
The anhedral angle. Now, I'm going to take us through the history of the Unitree bot. So this is the H1 hip. And the organization, this was what we call a RAF or RAF. It was like rotation, and then it was abduction, and then finally flexion. So flexion came last in there. Okay. So that is the original design. And then the next generation, they went to this, which is the FAR design that we have here. And we discussed this before, is that this right over here where my cursor is, there was like a hint of an anhedral angle here, maybe on the flexure, but it turned out to be more of an optical illusion. It's just the way that connecting piece to the abductor was sort of sculpted in there. But if you actually look at how those rotors are installed in there, they're definitely horizontal. So they had absolutely no anhedral angle in there whatsoever. So suddenly they decided to take something out of the playbook of P&D Botics with the Atom robot, which is the first one we really saw that has this anhedral angle. And that basically means these red lines, rather than being horizontal, are pointing down. And, what are the potential advantages of that? And we've discussed this ad nauseum in many different cases. And it turns out that in their case, the angle they have probably is even steeper than whatever it is that P&D Botics is using. So I went ahead and I put a protractor up there, and that looks to be like a 45-degree angle to me. That's quite drastic, going from never having one to going ahead and doing that. So that's a rather interesting thing. And this is one of the problems that having an anhedral angle might bring about, is the possibility of introducing a singularity very early. So now what I mean about that is that I went here and I kind of said, just imagine if you decide to take the leg and then rotate it 45 degrees about the abductor. And when you do that, now suddenly this blue line, which is your rotation here, becomes parallel to the red line. And whenever you have that alignment, you bring it into abduction or into the singularity. Now, it doesn't matter that these don't intersect. So, what I should do is go back up here for a second. And the other thing we might notice about the way these lines come in is that um, they are not concentric. So in other words, the center of the green circle and the red line and the blue line do not come at the same point. There's like a little bit of an offset in there. And it just makes it a little bit harder for the guy solving universe kinematics, but it's still solvable. And some people think it's a way of avoiding the singularity by doing something like that. And it's like, no, what you do is you might make the singularity, let's say, kind of less extreme in some regions, but you basically spread it out more. It, it basically makes the waters more turbulent, a wider area from the singularity. So there's absolutely no advantage. Now, what this means is if they need to get their, yeah, go ahead.
Sorry. Why do you go to anhedral angle again if it's really could bring a lot of problem in singularity? Like, what is the reason for that? Do you have an assumption why?
It's a really, really good question, and I can't really see why. There might be something about the packaging, because you notice the waist is very thin. And so what you do is that you kind of pull it in a little bit more potentially. So maybe you can get some bigger actuators in there and they don't quite take up as much space. So you get maybe a 30% saving, but that comes at the cost in the vertical. I mean, it actually makes it taller in the vertical. So I don't see offhand any real advantage. There has to be something about improvements in the motion. And we're going to kind of come back to that in just a second. But the main thing here is that, do you ever need to go 45 degrees? Maybe you don't. If you never need to go that wide, then it's not really a problem. And you think about it. I mean, spreading your legs out 45 degrees, that's kind of rare, unless you're trying to do the splits or something like that. And that kind of brings this thing up. Is pretty much what it means, is that it couldn't do this very famous split that one of the most famous actors from Belgium, Jean-Claude Van Damme, did a few years ago for Volvo Truck. And that as you get to that 45 degree, suddenly you're going to be hitting that singularity, and then you might lose control there. It doesn't mean it can't split out all the way. It can. It's just that it has to be very dangerous in that motion when it goes from the vertical to that horizontal like that as it passes through. So most other robots would not, those that don't have an anhedral angle, they won't hit the singularity until they're at that position, completely horizontal. Um, and again, that's more of a tongue in cheek. Do we need our bots to be able to be filming ads for Volvo truck? I don't know. So again, kind of going back to what P&D Botics did is they also in putting this in, they made some sort of decision. They were kind of first in two things. They were one of the first robot companies to really decide to go with a FAR design. Remember, everyone was using the ARF design at first because they wanted the flexure to be last. And P&D did this and also the anhedral angle first. And then we started to see some copying that. So if we look at Engine AI, they also had a slight anhedral down here. It's not easy to see. We have to kind of blow it up. And if we measure like this uh, right here, we can see it's about a 15-degree angle. Boston Dynamics also famously, has one in there as well, which we can see. This says 75, but we have to take the complementary angle. That's actually 15 degrees. Just that edge was much easier for me to be able to measure. And then, of course, one of the things that they sort of demonstrated with their presentation video is the robot being able to do this. So you see it's able to kind of turn itself inside out and go into contortions. Now, I don't know if having an anhedral angle facilitates that and makes it a little bit easier. It may have some advantages, but I don't really see it. So maybe if that's what you want to do. Here's another example from Limex Dynamics. And Limex, you may remember, is they had like this little bot that looked like right out of Star Wars. Those, was it the ATATs, that go around, the bipedals, and they were showing it running through the woods and being very stable, not falling down. And they have gone through several generations. So this, I think, is like their third generation bot. This is not their first attempt. They've been at it for a while. And you can see that once again here, if we measure what that angle is, while this says 60 here, it's the complement of that. So it's actually a 30-degree angle that they kind of have for that. And again, they seem to be showing it's able to exercise some rather interesting maneuvers. And I'm not sure if that somehow helps because it gets the leg out of the way of the body, but I'm pretty sure you could do it other ways, but I could be wrong. I mean, I really have to go through and see if that's the reason why, because they have a very interesting video. And I really encourage everyone to just go ahead, and you can find this on YouTube if you just type in like, Limex bot, because it's in really high definition and you see really good, sharp images of their mechanisms everywhere. So if you want to see how some of these ankles are done, how the kidney waste is done, oh, there's just some great shots here. There's also some great shots of the feet, but that right there, I wanted everyone to see. This is the downside of having an anhedral angle, is that when you go to flex, your legs will move out in a different way unless you compensate with abduction and rotation at the same time. And right now, I don't think they are. I think the abductor here and the rotation is fixed. And you see how suddenly the feet spread out like that? They slip on the floor because they're trying to rotate that, and that's the result. This is the other thing, the reason why you don't want to have flat feet. Remember we kind of talked about that either suddenly your feet are on the ground and then instantaneously they're off. There's no middle ground there. Just boom, you're right on over. But again, it's a very interesting video looking at the mechanics of everything is going on. So, and now the other thing we got to remember, when you're building a bot, you're not just thinking about whether the bot can walk. You also want to think about how it's able to do squats, because it may be very important to go down to pick up something. So you have to look at a lot of different positions, not just making sure that the legs can walk, but they can also get into a lot of very important positions. And that's some of the tests that they're kind of showing and demonstrating that you're able to do that with a bot. The waist rotation is quite interesting. And again, this is the kidney style waist, which you can kind of see rolling around there, where they use a parallel kinematic mechanism. And I'm going to demonstrate that in a second because Unitree and several others also use that kind of waist design, or have in the past. And then we get some other ideas of the capabilities of the robot, again, right here, twisting itself around like that so it can come up. Maybe that's one of the reasons for being able to do it is being able to get off the ground in that manner. I'm not sure the advantage of it because when you fall forward like that, your legs are down. Great, I can twist them around. But now that I've twisted around, I've added a 360. It may look like there is no 360 there, but you just added 360, and there's still cabling going through there. and, and that means those cables internally are getting wound up. And
How is
so
that?
that
Just
might be,
explain the cabling to
yeah,
do the movement. Just break it down. There's many things in this robot. Can you go
yeah,
back again?
yeah.
Can you go to the video
Oh,
again?
yeah.
Sure.
Oh, yeah. Let me go back up to that video, and then
Yes.
so
So there's a couple
we
of things.
see. Yep.
First of all, there is abduction happening when they have it spread out. There is abduction happening or not at the beginning
Right
when
here at the beginning, they're probably there.
this
Yeah,
abduction.
I think I'm not sure if they're doing any abduction there or not. So the deflection is they may see right there that is all being done just from deflection. So the abductor doesn't look to me like the abductor is attempting to move there. That's off because if it was, you would see that abduction kind of turning off in another direction, and that's as a result of that angle. And that's only a 30-degree angle. That's not the 45 that it appears that Unitree is proposing right now.
And how are they managing the cable? That's I think we discussed this in the another episode, the wiring and
Y-
managing all of that. How
Yeah, well, they set them up that they actually spool the cable around a little bit to allow it to wrap and unwrap internally. You would have to do that in some places, but if you go too far, so let's say it fell down and you get up that way, and then you fall down again, you try to do it again. Well, now instead of having a 360 wrap, you've got a 720 wrap. So it seems like at some point when you get up, you've got to remember to unwrap yourself. It might be a good idea. You do it too much, you're going to put too much stress on the cables. So while it's a nice party trick, I'm not sure that's necessarily ideal. I mean, it's one way of getting up off the floor, but the other way is, it seems like Unitree has already worked that out. They've already have examples of being able to get up off the ground. And maybe it's more of a forward motion and not that untwisting motion, but they may decide, oh, we want to be able to do that as well. And that's the only real reason I can see, unless and this is the other possibility is that we know they have a lot of experience with walking and running. They've done and they've done a lot with RL to improve the running and everything else. And they've evolved through a couple different hip designs. So it may be as they were experimenting around, they saw something in the RL that was telling them that, oh, we're overutilizing this axis or underutilizing something else. Is there some way we can do it? And it may be by combining the two together, you get like a compound rotation out of the flexure and the abduction. Maybe what it does, it causes you to have to use one a bit more and one a bit less. And if you do that, it might mean you can scale down the size of one of them if the other one is able to always come to an assist. And it could be a potential trick. And maybe they saw that in the RL. They went through and said, hey, guess what? If we play with this anhedral angle and look at the output, there's like an improvement there. So I don't think they just decided to do it without any informed decision making. They must have something that's telling them that.
when you say the combination RL, they found maybe something that you can have the rotational, like something that we show in Linux robotics, and what they have been doing in the past. So what the improvement is, like what the benefit could be.
Okay, I think what the benefit would be is that you're testing out the bots and you have a lot of different parameters, and one of those parameters might be power consumption. We want to be able to walk efficiently with less power consumption, or we want to minimize the amount of torque that we have to have. And you might be noticing that parts of your stride, there just seems to be a lot of torque, which means we have to get a slightly bigger motor. And then you begin to play with some parameters and say, well, what happens if we change the anhedral angle and then do these same things? Is there better energy consumption? So is a more efficient stride? Maybe there's some other kind of movements it's able to do. And it could be that they're running things like that, and it's a form of optimization right now. Because otherwise, I don't see why. I could understand someone wanting to say, I think a 15-degree might be a nice thing to add. Okay. But what ends up happening when you take a horizontal axis like this and you continue to rotate it down like this? So this is your flexure direction, right? And if you continue to rotate it and continue to rotate it, and eventually I get to there, what is my axis doing now? it's no longer a flexure, right? It's basically, I've got this up vertical right now on my axis. That means it's now I turn my flexure into rotation. Okay. So this is the thing is kind of strange. When you put it at 45-degree, it means it's half acting as a flexure and half acting as like a rotation. And you've already got a rotation that's dedicated for that. So I haven't quite figured out why you want to do that, because it seems what you're doing is you're almost giving double the amount of well, not quite double, but you're increasing the amount of rotational capability out of that and decreasing the amount of flexion capability that would have to be compensated probably by the abduction in some other. So there's a weird combination, but it might be that that weird combination has some benefits that is not obvious right now. And like I say, if you already have a lot of expertise in RL, if you've already trained these bots in RL and you're already able to see that we're getting really good, say, zero shot, and it's very predictive on what the actual torques are going to be, what the actual power consumption is going to be. Well, now let's just start using it for this inverse design, right? It's just like we want to get the power consumption down. We want to be able to bring our torque down. So you run that thing through a bunch of times, and maybe it says, hey, guess what? You put this thing at 45 degrees and you will be able to come up with it. Maybe. I mean, this is me speculating, but they have enough experience already that I just don't think someone just said, oh, it packages much better, or let's just roll with it. It's like, no, they had to go through and verify this is a good idea. You don't make such a radical change and just assume you'll have the same capability.
So your suspicion is maybe in the simulation, like sim to real, they did the design
Yeah,
modification. Because
yeah.
what can
That's
you remind me
it.
what was in the airlail version, like G1? What was do you think what was maybe pushed them only to do 45-degree? Is there something you think happened just make
Well,
them
let's
we have to do that?
part of it might have been that, oh, they saw P&D Botics is doing it. They saw that, Engine AI did it, but maybe they weren't quite sure. But definitely Boston Dynamics threw in a little bit. And then, certainly also they may have noticed that Limex was doing as well. So it's like, okay, there's a bunch of them out there that are playing with the anhedral angle. Let's play with it as well. Then maybe they just said, let's put in a 15 and see what it looks like. And maybe they say, hey, there's a little bit of improvement. Well, let's try 30. And it's like, wow, got even better. It's like, okay, let's try 45. And then maybe, and then said, let's try 50. And it's like, not so good. So they may have gone through and then found that 45 has some capability that is not obvious to us and definitely not obvious to me. I've experimented with this idea that if you have your angle off the 45, the way the leg goes down, what it means is the moment of inertia as seen by that actuator is going to decrease by about 30% if it's at a 45-degree angle. So when you go to calculate the moments of inertia, so that means it's actually seeing a smaller moment of inertia in a way. So there, from a dynamic standpoint, there are some advantages. Now, but that slack then has to get picked up by the abductor. And so there's no free lunch there. I mean, but basically what you're saying is, oh, wait a minute. If I can combine the torque of two of these motors to get the torque that I need, in some weird combination, sometimes when you take 45, if you take two vectors and you take their components that are 45 and you add those two components together, the two of those add up to be like 40% more than the length of the others. So it's like you can almost get a 40% increase with the two of them together. Again, this is just me thinking off the top of my head and kind of how vectors would add together. Now, it's going to change as you go through space because it depends upon what the gravity loading is. It depends upon the actual angle that the abductor has made at that point with respect to flexure. When it comes around to something else, all bets are off. But it may be that there's a little bit of advantage that you are literally having, both all oars rowing in the same direction for a while at the same time. And you get that extra boost. And if that happens, two things can go on here. It says, hey, guess what? I can reduce the size of the torque on that flexure. That's a possibility. And then maybe you always needed to have the abductor have a certain amount of torque in there. So you're not making it smaller. But you may be looking at it and says, you know what? We barely use the abductor. We just use it for like when we're losing our balance to get around. But when we're walking, we never use it. It's sitting there doing absolutely nothing. And actually, It's not doing absolutely nothing. This is something that someone pointed out in one of the Reddit threads that I wanted to address at some point. They asked a very good question. When they're standing still, are the motors drawing current or not? And it's like, actually, they are drawing current because they're back drivable, remember? So even if the bot's not moving, in order to stand, well, you do it yourself. Pick this thing up. My arm's not moving. Why are my muscles getting tired? It's because I'm having to apply a torque. And torque, yeah, you do not torque does not necessarily mean acceleration. Torque means you're fighting like another torque, which is the gravity loading that's going on there. So just kind of walking and stuff like that, there may be situations just to keep the leg in the position needs to have the abductor's got to work anyway. And so you might be saying, well, heck, it's taking a little bit anyways. Why not just go ahead and put it to full use? And so it could also be that you're taking some of the wear and tear on one joint and you're letting the other one pick it up, one that's not going to getting a whole lot of wear and tear. Again, I am just coming up with crazy ideas. I cannot say that that's necessarily right.
I think this is interesting, and I'm really curious when they reveal it. I think you will have more clarity about why they did this design choices. But do you think it's driven also by the amount of money? Because it just always boggles my mind how Unitree managed to give this manufacturing cost, and of course, if we say you sell it like 9K, how much actually it cost them to produce this in house and then sell it to this customer? It just boggles my
Yeah,
mind
it,
how
it
we managed to do all of that at this price tag. Because it seemed to have, maybe they have. If it's
uh,
9,000, it could be 4,000 to
mhm.
make it. It's just
It would
crazy.
have to be, or or it's just trying to get market share. It may be that so long as they make a dollar on each one, they say that's fine for now because we want everyone to be getting out there and using it. Uh, the other thing is these actuators. Part of it might be if we can simplify the actuator design or not have to have a super high torque one because we do this and we make sure that the flexure and the abductor is the exact same motor, and they're producing a lot of these rotary motors because they're very similar to what you would have for drones. So they've got a lot of capabilities like that. This is not a very tall bot. When I saw it in person, I was surprised how small it is. Okay, it's 35 kilograms. It's half the mass of like a Figure, Optimus, and the others. So it's a little bit lighter, which means not as much battery and everything else. So in many ways, and remember, it doesn't have hands yet. So that's the complexity, that the real complex part is when you go and get the hands. So they're able to produce these and that's the thing is once you start producing them at scale, man, your prices just drop. So if they're only producing one or two of these things, they don't have a whole lot of interest. And you've got that, the elasticity of the supply and demand curve. They may realize that we get it below 10,000 and we will sell 10 times more units than if it's over 10,000, and as a result of that, they might be able to see that the prices go down.
Do you have an idea of adding hand? Because I think now merely just universities buy these spots. I don't think anyone uses it for like industrial
Yeah, yeah,
sites.
yeah. They
So,
they have a hand, so
how much
they
will
they
be
don't
the.
have it on this bot. So,
Okay. Okay.
it probably would be almost the cost of the bot itself, if not more. So they have an upscale version of the G1, which already goes like for $69,000. So they have like an entry level one, and they have one way up there. And so what they're trying to do is get down that lower end of the market. It doesn't have hands, but we have seen that they are working on a hand, which will be rather interesting when they get it out there. But that's not going to be on a $9,000 bot. That's going to be much higher level. But it could be that depending on how successful this is, people are then willing to either get it as an add-on or decide, okay, we're going to upgrade to that version because we're so happy with what's going on here. But there's still a lot more to tease out on this.
Scott, I'm just curious because do you have any idea how durable is this robot now? Because I heard some people say it doesn't last too much. It's not that.
Mm.
So how
It
much?
doesn't last very long. That's the thing, and part of the reason might be the reason to do that is maybe they found a couple that joints that are wearing out because they're getting too much use, and maybe if they can spread the load around a bit more, they might be able to get more usage out of it. That's that's a possibility, but yeah, you've heard me use the analog of the bot Athesius, that if you have to replace all the actuators, is it still the same bot? And it seems like there are quite a they don't. I've been hearing 60 days and stuff like that, and that they can wear out. But that's what I've just heard from others I don't have personal experience on that. But again, if we kind of go back to it, we know the bot can get up off the floor, so I don't exactly see why that's needed. And that was like a real kind of uh, side table discussion there about what's going on with that anhedral angle, and we've only just covered the hip. We still have a lot more to go here. Okay. So once again, in conclusion, we can look at all of the different bots that are out there. And if I do the comparison, you can see you go from 15 degrees all the way up to 45. And yeah, I'd forgot that. I'd always, for some reason, in the back of my head, I thought Adam was at 45. No, it was only at 35. So that is really something else to go up to that level. So they must have seen something in their training results. Okay, where should we go next? If we look at the hip, the next place will be to go to the waist, because we've got the 6 times 2, and now we're going to go to the +2. And so that's what we're looking at here. The +2 is the waist. Now, if you look at the options they have, they talk about that the waist degrees of freedom is 1 plus optional 2 additional waist degrees of freedom. That does not mean a 2-degree of freedom waist. That means a 1 plus 2, or you end up with a full 3-degree of freedom waist. And they've had, let's say, a lot of different, and for example, I just wanted to show here, this is what their kidney style waist would look like. So you have a Z rotation, and then you have this mechanism here, which allows you to have X and then Y built in. So that optional is this upper bit above the blue part down here that you can put into some of their bots. So they have experience with a 1-degree of freedom wrist or waist. They have experience with a 3-degree freedom waist. So they've had a chance to kind of examine what are the pros and cons of these different style waists and what you can and cannot do with them. So, for example, let's take a look at what they show their bot doing. So here's walking with a full 3-degree freedom waist. And if we look at this, we can see, and that one there, it was going that side-to-side bending. And then when it was running there, we can see how it was like using the Z rotation. This one uses the Z rotation a lot. As you see, it's very important for the move it's going to do. And you'll see it doesn't actually have an X bend. It's not able to lean forward, but in many cases, it's actually able to. So again, reviewing these things here, it's not leaning forward, but you notice it's got the side to side and a little bit of the Z. So it's almost like, we've got a degree of freedom here that we're not really using for that walk. For the running, we can get away with just a Z rotation. And then we're going to see a little bit like this one right here has only a Z. Yet you can see, look at the bend forward it gets. It doesn't have a waist for doing it. How is it doing it? The redundancy in the hip. So you don't really need what's the waist Y. You can say it's not necessary. Look, in this case, they just had the Z, and they're able to get more than enough movement out of the bot to accomplish everything. So they probably came to the conclusion that we don't need that. And remember, they're not the only ones that kind of come to that conclusion as well. So what I believe is that they've got a Z and an X rotation. The question is the order. And I was assuming at first it's like a Z rotation and then followed by an X. And I realize I'm probably wrong on that. I think there is a difference here of what they've come up with. And that is, the first thing is again, going back to Adam and what they did, is that here is the waist that P&D Botics came up with. So again, they have the nice anhedral in here, and that anhedral opens up this huge space right in here for them to put an actuator in. And that actuator was that X rotation right there. And then they put in a Y rotation way up here, and then the Z came last. Oops, sorry. Let me get back to there. And so then they have the Z up here. Well, if you just drop the Y out of that, you would then come up with like an XZ kind of rotation that would make sense. And again, if we look at some of the other waists that are out there, I call this a lowercase y, because you're getting the Y for free from the hips. So it doesn't really count towards the waist. It's really an X rotation and a Z rotation. So this is the figure, F2, and Optimus does the same thing from Tesla. So that is a common, let's say, solution to the waist problem that's out there. And so what they've probably done is the same thing that we've seen in Adam, as I suspect. Again, looking at the silhouette, it's sort of hard to tell. I think in there they've got the room for that actuator, because this actuator up here doesn't look like actuator for rotating in the X. It looks like the actuator that you would use for rotating in the Z. So that's probably right there with the X actuator, just based on that silhouette. So that's
Do
my
you,
guess
do you think
is
this silhouette?
that the mhm.
Do you think this silhouette is the real robot? Would be the same? This silhouette they revealed would be the same shape of the robot because it seemed like cartoonish to me.
Mhm. Um, I think it will be. And again, I see I made a mistake here. I got everything moved around where it's supposed to be, and this should be XZ, not ZX, right? So I believe that's what they are. I think it probably will be that and this is a very funny if we kind of look at the actual shadow. This is more of a silhouette than a shadow because I've never seen a shadow cast a shadow, which you can see down here. And there's also some textures and other things that we're able to see in here that some details they want us to be able to see. I think it probably is correct. I don't think that's like a distortion or anything else. I'm pretty sure that is what the bot's going to look like. And if it's not, then it's just a psyop to kind of confuse us on what they're coming up with. Um, but it's interesting they've come to the conclusion to go with the anhedral in the waist, or sorry, in the hip, and that in the waist they've also come to the same conclusion because remember when we were looking at the spaces of all the different designs, the hips were all over the place, and then suddenly everyone went with far. Not everyone, but let's say like 90% of them have all gone to there, and no one's really experimenting anywhere else. The waist, we've been all over the place, and we still are. Everyone is experimenting with it. And so now it seems like they've come to the conclusion from the data, looking at everything, said, look, you only need 2 degrees of freedom in the waist, and that's it. And we're happy with these. Now, what might be interesting is the, that the way that they've put this anhedral in here, I that takes away kind of that Y rotation that you normally can get in the waist. So it's going to be really interesting to see. I mean, you can still kind of use it, but it may behave in a very strange way. But still, Limex was doing it, and they were able to do like the parallel squat and everything else, which kind of requires that bending in the waist. But then again, they actually have the full 3 degree of freedom waist. So, but still, a lot of it I think is actually coming down through there. So they've come to that conclusion. And the question is whether their higher end bot is going to go the same way, or is this just an idea for a low end bot? Okay, now, ready for the next one?
Yes, shoulders.
The shoulder.
No change.
So, and again, I've kind of given it away. It seems to be the same shoulder.
Yep.
There hasn't really been any change. It's a far shoulder. And so we can see exactly where the flexion is. We can see it's a dihedral angle that they have here instead. And we can go ahead and measure that. And that's 15 degrees, which I think is about what it was before. And again, that makes sense to stay away from the singularity, whereas an anhedral angle is kind of a bad idea because it makes a singularity easier to get to for the leg. A little bit won't be that bad because we don't tend to spread our legs way out like that very much. So maybe you get up with 45 degrees like they did, but here, 15 is okay. You could even go higher. Now, the result of this is again, we don't have these things concentric. So you see where the red and the blue axis does not intersect at the center of this rotation. And again, there are details in here. We can see a circle right in the texture that's there. It's kind of hinting that that's a point of rotation. And again, that profile matches really closely to the G1. Now, part of the reason they have this offset is that the more dihedral angle you introduce, the harder it is for you to get those lower angle rotations without kind of self-colliding into things. So that offset kind of helps with that. So you notice like there's a little cutaway here. So by doing that, it makes sure that the bicep doesn't bump into the torso very easily. So that's part of the reason for that offset. It's just to make sure you have enough clearance. And the blue arrow I put here is that you can probably notice right here, this is sort of telling us that's the point of rotation. So when you look at most of the arms, you're going to see these kind of splits where you can tell one section is rotating from another. So this is going down the arm. We can see exactly where the elbow is now, and we can see where the wrist joint is along here, rotating along there. And the profiles are, again, very similar to the original G1. So if we look at the G1 and compare the two, we can see that, oh yeah, it looks like they probably have about 15 degrees here. There is that little bit of offset. We can see exactly where the rotation of that happens. And then this becomes more of a kind of a conical uh, geometry here, going from cylindrical to conical down here, which is what we were seeing actually in there. And you'll see also the same kind of silhouette here with what's going on with the elbow. It all almost matches one to one in where that rotation is. Now, there is something else they do that, again, kind of goes the way my thought process, which is why I almost like looking at Unitree, is that we seem to align on some of our thoughts. And this we mentioned kind of last week about the way you think of an elbow. So here they talk about, the shoulders 3 plus elbow 2, and then wrist 2 optional. So this is the high end G1 where you can see they actually do have the wrist. And the way you look at it, at the problem is they're seeing it as like the shoulder is a 3-axis problem and the elbow is a 2-axis problem. And a lot of people say, wait a minute, the elbow is just one axis, isn't it? And it's like, well, it is, but it's basically a viewpoint that you can have of where the mechanics actually belong. And they really see as the elbow as having these 2 degrees of freedom here. And that is, you see there's a rotation that goes along here. And the question is that motor closer to the elbow or is that motor closer to the wrist? From a standpoint of kinematics and the math, it doesn't matter whether you consider that to be part of the elbow or part of the wrist. But from a mechanical standpoint, and actually from a dynamic standpoint, it does, because the more the mass is up by the elbow than down here, the better it is overall. So again, I like the way they frame the question. And this is the way I want everyone to and we're going to see an example here, which is going to be, I think, shows that thinking the problem differently will give you a different solution. So they don't consider that part of the wrist. They consider that part of the elbow. And then the wrist they see as a 2-axis problem, not as
Can
a
I ask a
3-axis
question?
problem.
Is it if they say
Yeah,
the elbow 1 and the wrist 3? Since you say it will be different if they say it's a part of the wrist, not part of the elbow.
yeah. I mean, it is and it isn't. A lot of people, when they look at the bots, are seeing a wrist that looks like a 3-axis wrist. And the reality is it's a rotation plus 2 degrees, another 2 degrees. It's almost like a 1 plus 2 problem as opposed to a 3 problem. And I'm going to get into that with a couple of examples to kind of show. So again, it comes down to, where do you associate the mechanics of where everything is happening? Where do you want it to take place? Do you want to take place in the shoulder and the elbow? You could even consider the elbow a 3-degree freedom problem. So like this rotation that we see right up here, you could almost think of that as belonging down at the elbow along with that one there. So it could be the shoulder is 2, the elbow is 3, and the wrist is 2. That's another way of just thinking mechanically. And it comes down to how you integrate your systems together. Are they all separate individual pieces, or are some way you think, how do I combine these together to get some sort of advantages? By the fact that if I think of them as being a combined unit as opposed to separate units, I can probably integrate things a lot better, reduce mass, maybe get better capability out of it. So it's just, I think it's an important mindset to see things differently, to realize there's more than one way to approach a problem. And sometimes the other way of approaching a problem is where you get the insight and sometimes where you get better solutions. So again, I like the way they framed it, because it's like, you know what? I think of it that way too. So bravo to Unitree. I like that. So again, what I want to do is like, here's a classic example of thinking of the wrist as just a 2-axis problem. We've got the pitching and we've got the yawing. And we know that this is a pretty famous solution that we've seen in several of the different robots out there, that, the blue section can rotate completely. And you can think of that as belonging to the elbow upstream, because, that first rotation doesn't really contribute anything to what's going down here. But what's happening on on this with the yaw and the pitch is that both of these are required. You can't take one away. and the system won't work anymore. They're both required as part of it. So in other words, you've integrated them into the overall solution. So it's really a two-axis wrist plus a rotation in the forearm that could take place anywhere. Okay. So that's, and we've seen that this shows up in at least four different robots out there. This is a robot from Medea, which people may not be familiar with, but it's basically using the same kind of actuation strategy for a two-axis wrist as we see in the Aptronic Apollo, of course, from the Tesla Optimus, which is probably the first time everyone was introduced to this idea. And over here, the Iron Bot from Xipeng also does the same idea. In all of them, you'll see there's that split right here where the whole forearm assembly has to rotate. So you have that single rotation that's occurring just below the elbow that rotates the entire forearm. And then inside the forearm is the thing that solves the other 2 degrees of freedom. So that means you're really thinking of the wrist as a 1+2 problem in this case. All right, now here's a different example of a wrist solution, which comes from Pollen, which is now part of Hugging Face. And this is what they have on their Ricci robot, where it is a fully integrated three-axis wrist, no doubt about it. You take away any one of those degrees of freedom and it doesn't work. You need all three of them to be able to get these 3 different rotations. You can't split it off. It is a legitimate 3-degree of freedom wrist, integrated in there. Rather interesting, novel design you see there. And they've used it, I think, to pretty great effect. So we can see some recent images that have come from the Ricci 2, where over here on the right side, you can see how they've integrated that now into the wrist. It used to be it was only up in the neck. So they get 3 degrees of freedom up in the neck that way. And they've now managed to come up with a solution down here. And what's really interesting is that platform they have. You can see they have a ball right there. So it rotates around that ball. They have a shaft coming through here. And I suspect that shaft is so they can route the cabling right on through to the hand. So it's not exposed or wrapped around the outside. And you can see these 3 different cylindrical rings, which I think, sorry about that, which I think are actuated by motors that are up here in the forearm. So you have 3 actuators up here in the forearm that take care of it. It's actually a 3-axis wrist. But if you look at the way they look at the shoulder joint and they look at the elbow joint, it's rather curious because when I was looking at the shoulder, I was trying to say, wait a minute, I see that rotation here for the flexion. I can definitely see this thing here for the abduction. How are they doing the roll? The roll is not happening up here. The roll is actually happening down here at the elbow. Okay. So they do the roll in the elbow, and then they also do the normal flexion of the elbow as well, what we usually think of as the elbow joint. So again, Pollen has broken the problem down. They're seeing it as a 2 + 2 + 3 problem. A lot of the other manufacturers out there are seeing it as like a 3 + 1 + 1 + 2 problem. And depending on how you look at it, it's a different way of designing your mechanics to take advantage and leverage capabilities of one over the other.
So there
So,
is no pro and
it's a different
cons.
way. Mhm.
There is no pros and cons for the different mindsets.
No, there's no. I mean, kinematically, these bots are all the same. They're accomplishing their 7-degree of freedom, human-like arm, and they're gonna have the same kind of similar capabilities. Some of them might have a better, range of motion than others as a result, but, everything about these robots is gonna come down to actuation and packaging. And in many cases, everyone is building one axis at a time. I need a good flexure, so they build that. Oh, I need a good abductor, and then they put it on top of that without thinking, well, how do I integrate the two? What is there some sort of scheme that I can put all 2 or 3 joints somehow together to get some sort of advantage out of it? And for the most part, they're all saying, oh, I'm just going to focus on my problem. I need to solve the abduction. What's the actuator I have to put in there? And the other mindset is like, well, how can I solve both of them in one? Well, what kind of approach can I take, and what advantages would I have? And some of them, as I think we've seen in the orbital actuator, is one of the advantages here is that all of your actuators are down here in the cylinder, and you're not carrying the payload of those. So it's kind of a parallel actuation strategy which has its advantages as well. So again, you can look at these as a different way of solving that problem by looking at the combination of several joints together. I'm not going to say which one's the best. I'm just going to say the mindset is great. Every designer should be taking that mindset and thinking about it, that if I have a two-axis wrist problem, what am I doing with that first axis, the rotation, the forearm? Am I thinking of it as completely a standalone thing that's sitting on out there? Or wait a minute, maybe I can somehow combine it with my elbow. And if you're clever about it, maybe you get that actuator that's in the forearm right now behind the elbow. You could use some kind of mechanism like what we're seeing here to say, oh, you know what? Maybe I can get the actuator for that above the elbow. So that helps me from a dynamic standpoint. Lowers mass, does a lot of other things. So it's more or less just kind of the mindset that I would like everyone to take.
What is the downside of musical
All
question
right.
from bowling actuators that they used in the head in the arm? What is the downside? Because it sounds to me elegant solution. I didn't see, to be honest, and
Mhm.
I know we covered in the orbit actuator still, but which will be published soon. But what is the downside? I think the load, they take all the load, but if there is anything you think about the bowling actuator, the way you have to rotate the three parts to make the desired
It's
motion.
it it's I mean, there's so much elegance to it in a way. First, it's very stiff. There's no doubt about it because you've got the loads taken by all 3 of them at the same time. So that means when you go to grab something, you don't have any weak link or an actuator that doesn't have enough torque and suddenly it just can't hold that dumbbell or whatever it is. And it's kind of like a Stewart platform. That's the advantage of a Stewart platform is that they're really rigid and solid or tripods or anything like that. So whenever you see those things, the first thing your engineer's mind says is like, "Oh, I bet that thing is rigid and stiff." And it's like, "Yeah, it is." The other is that in order to accomplish just about any rotation, there might be a few. I think all 3 actuators become part of the game. So that means whenever you need like a lot of power in one direction or a lot of speed, it's like you got all 3 of them working for you. You don't have 2 of them. They're sitting around waiting. Then there's the parallel actuation strategy. The fact that none of the actuators is carrying the mass of the other actuator, which is you would love to not have to have that problem. So it's just absolutely elegant, and I like the approach. Now, the downsides are going to be there still are some. I wouldn't say it's complex. I mean, in many ways, that thing is so elegant. The linkages are very simple. The joints that they're actually using, I was surprised. They got away with cylindrical pin joints on that whole thing. There is not a spherical joint in there at all. And that means it's not going to be sloppy. It's going to be very stiff and rigid, which is a huge advantage and easier to manufacture. Very simple linkages. They're all identical, so you don't have to to worry about, different part numbers or anything like that. And if but the structure also has some natural asymmetries, which could be a disadvantage. But if you line it upright, it turns out that there's like a very favored direction that it likes to kind of move. You can get 90 degrees in one direction, but unfortunately, the 90 degrees is like 60 this way and 30 back. It's like that's exactly what happens with with my human wrist. I can't go back much more than 30 this way, and I get okay, it might be nice to go a little bit more than 60, so it doesn't quite have all the pitch. And then the yaw back and forth is like plus or minus 35. Well, that's about exactly what I have. So it's it's really remarkable. And I think they could probably do some things to optimize it, make it better. And then you do have some bits that are sticking out that can get caught in stagnant things. Yeah, but so does Optimus and the others. I mean, those things are going to have to be covered up. So everyone that's using an actuation strategy similar to that has the same problems. But there's seems to be, let's say, less things getting caught. It's absolutely it's very elegant, and I have a feeling that once enough designers look at that and really think about it, how could we repackage it? I would not be surprised if that starts to get more popular. Yeah, I think it's a really great idea for the neck. There's so many ways it could fit up in the neck and do very well with the payloads. And I'm assuming you might be able to, it's just that the range of motion might be limited, but the range of motion for the neck, it's almost perfect. It's 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 a very clever, very ingenious design that I'm the more I look at it, the more I like it. And I was like,
Yeah. To be honest,
yeah,
before saying what my impression about the bowling actuator, because we have maybe a teaser, we may have them soon on the podcast. The
yes, we will. Yeah, and hopefully it will be an in-person interview. So probably several weeks out. Um, the worst case, it's virtual, but we're hoping to try to make it in person because I see this is what I like. What I like about Ricci is like there's a lot of out of the box thinking here. Again, that wrist and that neck is completely no one else is really doing that or deciding to take that approach. Their idea of breaking the problems down into like 2 plus 2 plus 3 like that, looking at it that. This is the mindset everyone has to take to be able to make these next humanoid bot designs that have the improvements that we're hoping going to be there. So it's understandable from your first generation is going to be like that, but by the time you get to fourth and fifth, we're going to see some very novel kinds of joints, which I think will be very much like the pollen rest, the orbital actuator, which we have that we've already done the interview that will be coming out soon. Or maybe it already is before this one. I'm not sure when it is.
I think it's a lot of
So
episodes, but
uh,
maybe yeah,
yeah,
see. I
yeah,
think the one
yeah.
thing I want to
So
ask you.
to finish up, and
Yeah, go ahead if you want to
mhm,
finish yours.
yeah, no, 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 you shoot
I
away.
think, yeah, I think what I like about the Bullen actuator, the way they were designed, I think it's something as a designer, when you try to get out of the box, as you say, they didn't take their traditional path of doing things. And maybe the first thing when they go to design, forget optimization, how they tap in this idea. I think that's what's fascinating to me, that you're thinking completely different, but how to get to the source of the idea. I think that's I don't know
Yeah,
the
I think
beginning.
pa part of it is recognizing the issue. I mean, a lot of times when you're looking at designs and solutions, your engineering instincts, you just kinda look at it, you just go, "Oh, yuck, that's just awful," and you can see all the reasons, and you complain about it, and then you have to step back and say, "Okay, what is it I don't like about it, and how am I gonna solve the problem?" And their analogy is absolutely great in their paper. I'm stealing their analogy because it's just so good, and I think we talked about it last time. The idea is that if we wanna lift up a couch, and the way to do it is that, there's 3 of us, and one gets on my shoulder, and someone else gets on another person's shoulder, and that person picks up the couch, okay? So that means not only am I having to lift, the mass of the couch, I'm lifting the mass of 2 people on my shoulders. That's what goes on with these serial actuators, is that the more of them you put on down, the more that and of course, the logical way to pick up the couch is for all 3 of us to grab a side and pick it up separately, so we're not carrying each other's mass around. And, you know, that's probably what just kind of bothered them. That's the problem. It's like, okay, how do we solve the problem? Okay, we've got to figure out how to get 3 people working together, moving this wrist around. Are there any examples of that? Well, there's the Stewart platform, which is a very famous example, but it uses 6 actuators moving around, and it's able to like move a house around, basically, something of that size, because it's used. The Stewart platform is not only used in machining and NC machines in some examples, but it's used for flight simulators. So you have like a whole cockpit that will be up there. And actually, I think Hollywood also uses it in some scenes when they want to have, things moving around to show like an earthquake scene. These things are just like really rigid and stiff. They have a limited range of motion. They can't quite do everything, but they're really pretty impressive. Um, by going to and now the thing with the Stewart platform is because it has a 6 in there, you can get position and orientation. The polymer's design is specifically designed, it can only do orientation. It doesn't change. So what the genius of it is like the center of that stays fixed. You don't it just there. It just rotates about that point. And you can't move that point. It's like, great, I don't want to. I want it to stay fixed because it makes the solution to everything a lot easier. So it's like, oh, that's just absolutely great. So you choose where you want that center of rotation to be, and bam, you've got it. So this is again where I think I would like to see more people thinking about that problem and rephrasing the problem. Turn the elbow into a 3 degree of freedom problem and see if you get any benefit out of it. Think of it that way. Think of it not just what's happening at the elbow, but what's happening before and after. And then how would you be able to solve the 3 of those in one shot that would be more elegant? And then, same thing with the shoulder is that, is there a better way to solve the shoulder than we traditionally are right now? That's kind of like, and I don't know if this pollen solution would work. It could be. I'm just gonna try to throw one together. But again, this is like we're completely off topic now here, but it's all right. So I'm gonna go back to finish up the slides I have here because we haven't got to the last part here. And let's if we get back into the Unitree, we've done everything except the neck. And so I'm pretty sure it's what you might call like a pan tilt neck, or it's a rotation plus a flexion. And the reason they put that in there is they decided that they needed to get the camera positioning. And it turns out that they have a bot, which is, I think, called the G1 Comp for competition that's being used to play soccer. And they had to mount their camera system up there and actually put on something that would allow it to move around to get the pan and the tilt so they could sort of see what was going on. And so they've now so that's this example right here. Yeah. So the Unitree comp, G1 comp, where they have it up here and they have these different degrees of freedom. So you can see the pitch, which would be forward looking down and then back up a little bit. So you can't see quite vertical, but you don't need to see quite vertical. And then also the yaw back and forth, being able to rotate to the left and rotate to the right. So they saw a need for it and said, okay, the next generation, let's just move the whole head, and they built that on in. So yeah, so that's the G1 comp taking care of that. Now, this is like the fun exercise I want to go through is that um, let's say I'm completely wrong. I could be completely wrong here. Because my first instinct when I was looking at it is that, 6 times 2 and then the 5 times 2, I was thinking, okay, they could be the leg, but I'm wondering, it's like, could they be mixing it up? Could they actually mean the arm is 6 and the leg is 5? So let's explore that because sometimes the best way to tell if you're right is to try to prove the counter argument. And the thought that I'm having is like what you can do, could you have a 6 degree of freedom arm or a 5 degree of freedom leg? Does that make sense at all? And why would you do something like that? So, looking at this is it's kind of hard to tell at first until you zoom in what's going on. And I had some ideas like, well, if we go back to the original Optimus, the design was not for a 7 degree of freedom arm. So right now, everyone's doing a 7 degree freedom arm when they're getting the hand in there. They've all decided that that's sort of the standard you have to do. But original Optimus was 6. As a matter of fact, when Bumblebee came out, it only had 2 degrees of freedom in the wrist, but it had 3 degrees from up at the shoulder. And part of the reason they did that is I pointed out before, we don't have a whole lot of movement here in this axis, so we go to a lot of effort to get it in there. And it turns out from the shoulder redundancy, you can take care of that. Now, industrial manipulators are just 6-axis. They're not 7. They started to have some that are 7, but for the most part, they stick with 6 because they have a super flexible wrist. But some of them decided to go ahead and put in what they call the elbow redundancy. And as a result, you can kind of get that movement just by what you have up here. So if you really wanted to, say, well, I'm not going to have the robot that has like, super flexible and super dexterous and all these things, but I probably could get back by with a 6-axis wrist, which would make sense if you put it up here. I can simplify what's going down on the wrist. So it's possible they could do that. But then you come down to what about the 5 degree of freedom leg? Does that make sense? I mean, do you think you could build a robot leg that walks really well that would have only 5 degrees of freedom?
I don't think so.
Would you, especially if you had like a lot of data, a lot of testing, a lot of examples, real world test data, would you say, could you do it with 5? And if you did, which is
Unless
the
it's
axis you would
redundant.
throw out? Because remember,
So
this is
when
my
you s
favorite question.
yeah, let's we
Yeah,
always got abduction, rotation, and flexion, right?
right.
3. So you'd say now
Yeah.
5.
And,
So
and
it
it's, and it,
seems mhm.
yeah, it doesn't see.
It's possible. I think it's possible. It's possible.
And some people always wonder, it may be, and the question is like, how would you do it? The arm we can do it because we've added redundancy with the elbow, and we could either take away one of the shoulder or one down here. So that's the easy choice. It gets a bit trickier. I mean, because in some ways, when you think of walking, you should be able to do it with 5 because the reason you put that 6-axis is that you're kind of concerned about how the hand touches something in the end. And so long as my hand is on the surface, I don't care if it's like this, if it just has to be flat. And that's the same thing with my foot. So long as my foot kind of comes down, it's flat to the surface. I don't care if my toes are pointed in or out. I really shouldn't care. And that's why the legs, the ankle is just 2 degrees of freedom right now. We don't have 3 in there. So you could almost argue, well, couldn't I take something away in the hip then that would allow me to get rid of that? And which would be the one I'd get rid of? And the way that we got to turn this thing around is like, what's the most important joint? What, if you're going to make a walking robot, what's the one joint that you absolutely would have to have, and all the
I
others
think
could you throw out?
rotation. Rotation is important. Rotation.
It's going to be flexion. It's going to,
Flexion is important.
well,
Okay.
the flexion is the most important one. You can build a
Okay.
walking robot with
Yeah.
just flexion. And there are toy robots that do exactly that. You wind them up and they go boom, 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 and they
Yes.
go
True.
forward.
True.
The
True.
thing is,
True.
they can only go forward, and that's about it. And they're tippy and they fall over and everything else. But it proves, but if you take away flexion, you can't walk. You could, if you have all the others in there, forget it. So we know it's like that's number one. The knee, we know you can walk with straight knees the whole time. You can bandage your knees up and you can get around, but you're going to find it's a bit of a hassle on non-flat surfaces going upstairs and stuff like that. You got to lean weird to get your leg around to everything else. You can get by with it, but you still would want to have it on there. Uh, and then, the ankle again. It kind of comes down to: do you need both those degrees of freedom to stay level? The one way you can get rid of it is like just get rid of the feet and just put balls there, like what they do with the quadrupeds. It's just like, oh, this makes it a lot easier. You just put a ball, but that seems to only work well for quadrupeds. For bipeds, it seems like the ball's not such a good example. You actually need to have a foot, and you want to be able to get a little bit of control. So you think you'd want to have that in there. So it's going to get rid of it. So it's got to be one in the hip.
I
So
think abduction.
abduction or rotation, which
I
one would
think
you take out?
abduction is not that needed. Rotation is important. I think because
It,
abduction. I know.
yeah, it's a hard toss up there.
Yeah.
And the abduction, the importance of abduction seems to be in balance. It seems like if you take the abduction away, the bot's going to fall over in many cases. So for the stability, it seems like you almost need it. Rotation might play a little role in it, but the biggest value of the rotation is changing direction. So if you don't care about changing direction, you can get rid of that. All right. So now, if we kind of look at what's being teased again here, I'll just go back and show again what they were teasing. The one thing we can see is that if this was a 5 degree of freedom leg, well, we can see it's abducting, comparing the left to the right. Oh, the abduction is definitely going on here. And if you kind of look down at the feet, whenever you abduct, you need to have your ankle kind of compensate. So when your legs spread out like that, right, your feet now are no longer horizontal to the ground, and your ankles have to compensate for it. So you'd still kind of need that. And I think we can kind of see that the ankle is trying to reposition itself to stay flat here. And clearly for, any sort of walking, you need the dorsiflexion that would be sort of the foot pitching up and down. And you need a little bit of that left and right in order to stay horizontal. So I would think they would have that in there if they were going to go that route. So that leaves like, would you get rid of rotation? What if you got rid of rotation? Remember what I talked about a little bit earlier? That if you take flexion axis, and if you rotate your flexion axis a full 90 degrees, you get rotation. If you put it at 45, and I'm almost wondering, it's like, so it's like, okay, if I was wrong in that they actually went 5 here, and they, that means the 6 would be up in the arms, and the 6 in the arms, you would think you would see some sort of pitching on the hand. And unfortunately, when we look at the hands here, they're not showing any indication that the hand can pitch. We can see definitely 3 in the shoulder. Oh, we can definitely see, what's going on the elbow and the forearm, but I don't see any activity out here. And the other thing that's kind of confusing is their hand is closed like that. It's making the okay sign, kind of like what's that about? Whereas their other hand, they always kind of showed it. So if we see in the past, what they've had, they do have a glove on there to give an indication. So I'm not quite sure what's going on with the hand because they're not indicating that they have an actual functionally working hand there. And I'm not sure the advantage of putting it that way. But going back to that, if you were to have a really strong anhedral angle, maybe you don't need a rotation. But looking at these cutouts here and everything, it looks like, I'm pretty sure. So let me zip back up to where I kind of looked at the first one here. If we look at, see right here where my cursor is? To me, And right over there, it looks to me that that's where the rotation happens. You know, I'm pretty sure based on that lower leg rotates.
Is there a rotation? There
So
is
again, I'm
rotation.
trying to contradict myself as much as I can, but you know, I'm convinced that based on what we see here from the silhouette and there, we have all of those. But if you really wanted to have only a 5 degree of freedom leg, then having that 45 degree might be one way of doing it, and still allow you to kind of change direction. I'm not sure with what kind of consequences. I still think there's like huge downsides to it, and I wouldn't personally risk it unless I had like someone running a bunch of sims that were able to demonstrate that that was actually a reasonable proof of concept, that it actually does work.
Just
So,
to
yeah,
understand.
that's
So it seemed from the silhouette there's
yep,
rotation in the leg. And you say the abduction. If
yep,
we have the 45-degree, the abduction could, if it's vertical, could be rotation.
mhm.
So if we have the rotation here, that means they have abduction? Because the flexion is essential. So
Yeah,
we have rotation.
they definitely have abduction. So like with the abduction and that weird flexion, you might be able to do something to get you enough rotation that you're able to kind of point your foot in the direction that you would want for turning, and then set it down, and then maybe allow you to come around. You know, the rotation is very good. It does two things. The first thing the rotation does is that when you take that step, it makes you rotate your leg out. So your foot is now kind of pointing in the direction that you want. And then when you lift your other foot up, now you do the counter rotation to kind of bring the whole body around. So the first thing is to like point the foot in the knee in the new direction. Then when you take it off, then your whole torso and everything kind of spins around. And they're getting around really quick. We saw Agility doing that when we did the walkthrough at, at the Automate. So Digit was turning pretty quickly just by spinning on that axis. We've certainly seen that Optimus with a ballet, how quickly it's able to rotate around now just by taking advantage of that. So that was the whole point of that. And why no one was using it sooner, I'm not quite sure. Maybe it was just a balance issue or something else. But that's the reason why it's there, is to allow you to change direction. And we know changing direction is very important for cycle time. If you can't change the direction, forget it. You're just you're not going to be able to accomplish the task. So, but this is a $9,000 bot. Okay. So if you wanted to cut corners, that'd be one way, but I don't think it is. I'm pretty sure it's the same leg.
When will be released? When will be officially released? They didn't put a date for the official release.
Oh, that's a good question. Coming soon. I mean, whatever does that mean? Whenever like a movie goes out there and they say, "Oh, you know, this movie is coming soon," has been released at, you know, when is it? Is it 2 months, 3 months, or something like that? So I have a feeling it's probably a couple of months away. And but it seems like if they have, was that silhouette produced from CGI, or was it an actual bot that they had? So I assume they're pretty far along in it. They're able to move pretty quickly. They're not a small company. We've seen that they have a lot of design iterations,
I think
and it's probably something pretty easy for them
they have
to put
operation in
together.
China. They have operation in China and South Korea. I remember from the interview. I'm not sure if they have in the
Hmm.
US.
Okay.
Just I'm not sure, but they have a lot of engineers in South Korea and
I think
in China.
I don't think,
Yeah,
yeah, and I think they have probably like sales organization, and distribution channels in the US, but I don't think anything more than that. And probably also in Europe, I imagine. I assume that they might have
but I
something set
think
up
the
there
main
for
engineering
people who are
team
interested in
in the
purchasing the
China and
bot.
the South Korea. But I see what you are a bit, I think, curious will
Mhm.
be the actual body. So let's see. Um, yeah, I think it was very
Yeah,
interesting. It's always,
yeah, yeah.
um, what we should name the episode. I think the upcoming release of
Oh, I
Unitree.
think the shadow knows. Just the shadow knows. Yeah, the shadow knows that that uh, we haven't seen the bot. We are trying to come to all sorts of conclusions just based on a shadow. Or technically, I guess a silhouette. Maybe it's not a shadow. There's enough clues just because we know it's another generation from the previous bot. And again, I'm trying to play this game of devil's advocate of like, well, I'm assuming this, but what if my assumptions are wrong? Can I prove the counter?
I
And I
love
don't
this.
think I can prove the counter one. I think there's enough information in there that it's definitely 6 degrees of freedom in the leg. 5 in the arms, because without the hand, you don't really need the full movement that's there. So what it means is that they can still do this with the hand. You get that much wrist action. You just can't do this. And then, of course, obviously, you can't do that. But for whatever it's trying to do, and maybe with the finger like that, maybe somehow set up designed to grip things in some way. Already is in pre-position that you can get it to kind of go over and snag something and lift it up, maybe as opposed to just a glove. So, they're showing a different orientation of the hand, and it might be being cupped that way. Just means, you can do something useful with it. You might be able to like pick up your luggage or something like that with it, and then walk around with it.
I think there's a lot of when I see in all of new startups coming in a space, and I don't know, it's a crazy amount of startup coming there, and I'm not sure, to be honest, when I see all the bots competing with each other. Even in Reddit, when I post, some people are cynical about these bots, and some of them excited. And I think the comments him about the wheel and the leg, I think it's still people debating about that, why we should use wheel. I saw your post in X about you do need to change your environment for the wheel, and I think that's the advantage of having really good
Right,
growth.
right, right.
But
I
it
mean
seems
that
too many. It seems
there
to me,
there
yeah, I understand the frustration. Too many companies competing in the same space. I'm not sure
mhm.
how they get the funding. To be honest, it's just like if they do the same exact thing. It seems Unitree by far is getting a good price point for these universities to buy their pots, and I think this is their business model. I think just they do that, and they sell it. And it works. It seems working well for them. So, but I'm not sure about the rest of these companies. Just like, yeah, I'm not sure, to be honest. There's just too many.
it's 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 gonna be hard. I mean, there's no doubt a lot of them won't survive. There's so many of them, but there's a good chance that a fair number of them will. Okay, so as far as like wheeled versus biped, if you think about it, 1X already has a lot of experience in that with their EveBot. It was originally a mobile platform with these kind of the scissor lift that brought the body and the torso up, and they got a lot of experience with that. And they decided that bipedal was definitely the way to go. That while there was a lot of early advantages in that you got mobility right away, you didn't have to worry about the bipedalism problem. It introduced a lot of other things, and that is your surfaces just have to be flat. Wheeled vehicles are not going to be really good on different kind of surfaces that are rough or difficult to get over. And like just in their office environment, which is typical in a Nordic country, is you have door jams all over the place. You got to constantly get up and over, and you can see in their videos they were constantly having to make these little ramps to be able to go up and down on those things because of that problem. So while you think the factory floor is like, oh, that's ideal, it's always perfectly flat, there's all sorts of things that you're constantly over. There's cables that are being put down where someone has to go ahead and make some sort of protection just so things like forklifts and others can kind of go over it. Also, wheeled vehicles tend to be more tippy than people give them credit for. They fall over a lot more easy than you think, especially when you get your bipedal bot up and needs to lean in. The other thing is it can be, and it also gets in the way. It has a big footprint and everything else. So while there's huge advantages, everyone would think like, oh, with power and with speed and everything else, we already have bots for doing that. We already have these AMRs that move things around the factories, and you don't need to have an arm on them. In rare cases you do, where it makes sense to put an arm on it, but usually the arm is at the loading end or the receiving end. It's not on the thing itself that's ferrying it around. So the reason why you have bipedalism is not to do these long haul things, but to do a lot of these very small, short haul things in an environment that was designed for humans, where the workspace is just got enough room for a human to be able to maneuver in there. And suddenly you bring in something with wheels, it's very difficult to get around. It may not be a level surface. They may have to step up and do everything else. And I think it's been pointed out appropriately that bipedalism will become a commodity just like the wheel is. you know, that at some point it'll just be just as cheap to go ahead and put legs on your bot as it will be to put wheels, and you'll get all the advantages of it. Does that mean there won't be bots that are on wheels? Of course there will be. There's going to be these niche applications, and everything else, but bipedalism is here to stay. It's going to have its advantages. There's going to be reasons that you don't want to put wheels on the bots, or if the bots do have wheels, they're going to be bipedal wheeled bots. The quadrupeds I seen out there with the wheels, was an eye opener to me that, oh wow, you can do it. But what made the wheels work was the legs. Everyone thinks what made the legs work with the wheels. It's like, no, no, no. You're not realizing it was the other way around. That's what it comes down to, is that the wheels became a really fancy foot for these things that allowed them and gave them some kind of capabilities. So that's really the way you sort of have to think about it. And that, and there's going to be different form factors, no doubt about it. But early on, you want to try to stick with one as best you can because it covers more things. And you'd be surprised once it becomes a commodity, even though it's not ideal for that particular task, it's cheaper than the one that's specific for the task. And that's the whole idea, is to bring the cost down. That's why things aren't as automated today as they are, is because a lot of things can be automated. It's just that it's so costly, it doesn't make sense to do it. And that once you have something that makes automation really cheap, then it's gonna go in there, and we talked about it before. I've seen examples of robots being put in, and it seemed like complete overkill. It's like, "Wait a minute, there had to be a much better way of being able to design the automation for it." And it's like, "No, there isn't, because we only have to automate this one thing. It's a little bit unique, and there's nothing out there that does it, and we don't wanna engineer the whole thing for that process. So we're just gonna bring this robot over here and program it, and we're done."
It's very very interesting, and I think what make the automation more cheap. I think that's the question. If we have to go for legged robots, because we had Nora episodes, for example, and they said, yeah, they have the newest robot. I think Nima. I remember the name. What's the name? I forgot. But it just, yeah, it's also wheeled.
Oh, no, the for anyone. Yeah. Yeah, the yes, oh, MIPA. So they do have a situation with that, and I think using, a bot like that will have limited applications that make sense, but in the more general case, it won't. So the in Germany, a lot of people tend to live in flats. Okay, they don't have a lot of stairs to go up and down. So in many cases, having something that just has to work on one level might work out okay as something that's going to come into the home and be like an assistant. But you're still going to have to move your furniture around a little bit and make space for this thing to go in. Hospital situations, hospitals, they're constantly moving gurneys and all these other things in. So they're kind of designed to have very wide corridors, access ways to their doors and everything to be able to get, so patients can get in and out. So they've already been kind of configured if you're going to bring them as assistants. So there are environments that may already be suited for it. These hotel environments where they're looking at these bots that come in and clean, it's like, okay, I've seen some really fancy, high-end hotels now that have these fancy showers where it kind of goes right down to floor level. You don't have anything to trip over, but that's a minority of them. So if you're going to bring them in to do the cleaning in there, that means you're going to have to re-engineer all these hotels. There's a lot of hotel rooms that have tubs and stuff like that in there that makes it very difficult for the bot to be able to get in the shower like they were kind of showing. So there's going to be all those changes. The other is that I don't know if you've ever been to a New York City hotel. Man, it's like it's narrow. I mean, it's one of those things that you stick your hand out and you can touch all walls. And if you want to change the sheets in a hotel like that, I mean, the bed's practically up against the wall, or you get like that much room between where the bed is and the wall. Good luck getting your wheeled bot to go through there to try to go and fluff the pillows or do whatever. There's like absolutely no access. So that means you have to widen the size of a lot of these things. So it doesn't mean it won't work in some hotels. There's a lot of hotels where it might be perfectly suited, but there's gonna be a lot of other situations where it's a lot trickier to do it with a wheeled bot. And then if you're able to find a bipedal bot that is also able to do it, then in the end you're just gonna say, yeah, let's just go with that because it's gonna be way more flexible.
Think it's interesting. I'm not sure. Yeah, I think, yeah, maybe we can cover this for another episode, but I'm not sure if you have any other interesting point to close this interesting episode. And again, I want to say something. I appreciate this episode uh,
Oh boy, man, I've
because I think before coming to this episode was a bit silly, disappointed, a lot of work, but this, oh, I'll be honest, Scott, this episode, I think people listening, for me, it's just therapeutic, just to get curiosity, excited, and creativity. I appreciate it. I just want to say that. Really appreciate it. Thank you.
yeah, yeah. Well, it's like an outlet for me. As soon as I saw that teaser coming from Unitree, it's like, oh, I've got so much to say. So I just needed to say it. And I try to do it in post, but I can only get so many characters in there. I got a lot more to say.
With some difficulty in the audio, I think it just we're trying to get this finished up. But thank you so much. And yeah, there's a lot of I think, yeah, there's a lot of things coming up. I think when we start the interviews, in person. So I'm looking forward to that as well. Yeah.
Yeah. Thanks, everyone. And till next time.